Okay, this lesson is on solving systems of equations using substitution. So our essential question is, how do you solve a system of equations using substitution? So first I have the three different ways we have for solving a system. One we've already done, one we're learning right now, and then there's another one that we'll be talking about later. So the first is graphing. So we did this last time where you graph two lines on the same coordinate plane, and then you find the point where the two lines intersect. So there's another algebraic way to do it without doing the graphing. You can use some algebra, adding and subtracting, some multiplying, and things like that to get your solution. So one of those methods is substitution. So we'll talk about how to use the substitution method in this lesson. And then the next lesson we'll talk about elimination. So now you could make a table, but that's less efficient and it's a non-algebraic way of doing it. We're not necessarily going to solve that way. The only time where that might be okay to use is if you're doing a work sample and that's part of your reflection to verify what you've done previously is correct and the correct answer. So then you can make a table to help you verify that your answer done a different method is correct by using a table in the reflection. Otherwise, we're not going to use the table much. All right, so let's do an example. I think I have two examples and a little practice at the end. So we're going to solve the system using substitution. So we have y equals 2x minus 3 and x plus 3y equals 5. So on the right, you'll see that I have steps. This first column is still the column that's for your questions. So after you've done the lesson, you want to go back and reflect on the lesson and put some study questions in that column. So, and then I have this split into two columns, the example where we'll do all the work, and then the column with the steps. So our first step, solve one equation for one of the variables. So you need to get the y equals by itself, like this, or you need to get x equals by itself, like this. And so first you would look in the two equations, see if either of them are already written that way. So if you look at this one, it's already written in that format, y equals 2x minus 3. So we're going to be using that equation to do our substitution. So the next step is to actually substitute. So you substitute the expression from step 1 into the other equation, and then you solve for the other variable. So that means you take this expression, because that's what's equal to y, you plug it into the other equation for the y variable. It has to go in the other equation. So then if I write that out, I have x plus 3 times, instead of the y, you're going to write the 2x minus 3, because y and 2x minus 3 are equal to each other. They're the same thing, so I'm going to replace it, equals 5. So that's where substitution gets its name, where you're plugging one equation into the other. So we need to solve this now. So we will use distributive property first. So x plus 6x, don't forget the 3 times 3, so that's negative 9 equals 5. We can put the x's together. So that's 7x minus 9 equals 5. Add 9 to both sides. So 7x equals 14. Divide by 7. X is equal to 2. So once you've gotten the value of one variable, you need to substitute that value from step 2, in our case x equals 2, into one of the original equations. So it has to go into one of the original equations. So that's back up here. So one of those two equations. So I'm going to go ahead and use the top one, y equals 2x minus 3. You're going to take your x value, you're going to plug it into the x spot. So y equals 2 times 2 minus 3, because the x value is 2, so that's the number I plug in. Order of operations, multiply first, 4 minus 3. So y is equal to 1. Once you have both values, you must write your final solution as an ordered pair. That means it's x comma y. You have to write it in that format. Otherwise, you've not yet given me an answer. The answer to a system of equations, remember, is the point where the two lines intersect. It's that ordered pair. So you have to write this as an ordered pair, 2, 1. It's that point. That is the point where those two lines would intersect. Next is to check. When you do the checking of your answer, you must check it in both equations. That is a must, because if you get the answer wrong, more than likely it will work in one of the equations, because that's the equation you use to get the wrong answer. So you have to use both to make sure that it does work in both. So our first was y equals 2x minus 3 was our first equation. Let me double check that. Yes, it was. So we're checking. So y was 1, 2x is 2. And now we're going to check to see if that is equal. So 1 equals 4 minus 3, 1 equals 1. That one does work. Now we're going to check the other equation. So x plus 3y equals 5. So we want to see if it works in that equation. So x is 2. 3 times y is 1. So 2 plus 3, because 3 times 1 is 3. 2 plus 3 is 5, so 5 does equal 5, so it does work in both. Another way to check, and a good way to use on your work samples as a reflection, is to then graph it to see if it does intersect at the point that you have found. So then the first one, y equals 2x minus 3. So the y-intercept is negative 3. So there's your y-intercept. We have a slope of 2, so we go up 2 over 1. And draw your line. Okay, so that's our first line. For the other one, you have to rewrite it first. Okay, so we get the y by itself. So you'd have, don't forget, get the y by itself first. We did this last time. Divide by 3. So y equals negative 1/3 x. Ooh, this is a little tricky. That'd be 1 2/3. So when you graph it, the y-intercept is at 1 2/3. That's about right here. And then we have a negative 1/3 slope. So negative 1, I go down 1, but I have to go to about the same point. I'm going to go over 3. 1, 2, 3. Remember, always to the right. You can go up 1 and left to go the opposite direction. Then you draw in that line. If we did it correctly, it should intersect at the point that we are expecting it to intersect at, right here. So that point is the point 2, 1, which is what we got before. So that's how what we did in our previous lesson ties into what we're doing in this lesson. Okay, so the graphing should give you the same answer as the substitution. All right, let's look at one more example. I have a shorter version of steps on the right here. So first thing we want to do is solve for x or y, so we have to get the x or the y by itself. So you want to look at both equations and determine which one is most convenient to rewrite. Okay, and if you notice in this equation, the x and the y, their coefficients are 1. They don't have any other numbers. So those ones are probably the most convenient ones to use. I'm going to do this one a little different. Last one we had it solved for y. This one I'm going to solve for x. So we're going to minus y on both sides. So I have x equals negative 3 minus y. We're going to take that and plug it in to do our substitution. So again, we're going to substitute this expression into our other equation for x. So that's going to go into the other equation for the x variable, because that's what it's equal to. So I have 5 times our x, in this case, negative 3 minus y. So I plugged that into where the x value was, plus 2y equals 9. Now we're going to solve for y. So distribute. So negative 15 minus 5y plus 2y equals 9. Negative 15 minus 3y equals 9. Plus 15. So negative 3y equals 24. Divide negative 3. y is equal to -8. So you found the y value. Now we're going to go back to one of the original equations. So either this one or this one. You cannot use anything else that you've done beyond those two equations. Because if you made a mistake, it's going to mess up the rest of the problem. You want to start with one of the originals. That's the whole point. It's very important that you go back to the original equations. You're going to have to do this in all your classes after this. And we'll talk in more detail why it's so important in the classes after this that you use the original equations. You have to use the original equation. So I'm going to go ahead and use the bottom one. So x plus y equals -3. Plug the y into the y spot. So x, this time it's a -8 equals -3. Add 8 to both sides. You get x is equal to 5. Don't forget to write your ordered pair. X must go first, so be careful. If you found the y first and the x second, make sure that your x still goes first in your ordered pair. And then the y is -8. So we got 5, -8 as our solution. Do the check where you plug it back into the original equations to verify that your solution is correct. So x plus y equals -3. We'll use that one first. X was 5. Y is -8. We're checking to see that it equals -3. 5 plus -8 is -3. -3 does equal -3. Now you need to check it in the other equation. So let me get the other equation down here. So that's 5x plus 2y equals 9. So we're going to plug our ordered pair. This is x, this is y. We'll plug it into the equation. 5 times 5 plus 2 times -8. We want to see if that's equal to 9. So that's 25 minus 16 equals 9. So 25 minus 16 is 9. So 9 does equal 9. It did work in both equations, so we do have a correct answer. One thing I just realized is I did not show you all the shorthand version as we were working through it. So the first thing we did was solve for the x and y. So that was the part we did here. Second step, we did our substitute and solve. So this was step 2. Okay, so this whole part right here was step 2. Step 3 was the other substitute and solve. So you take your answer, plug it into one of the original equations, and then solve. So the red was the other step 3. Step 4 was write your final solution. So this is your step 4. That by itself has 2 points. Okay, so if you don't write it, you don't get those 2 points. You have to write the ordered pair. Then you check in both equations. So that was number 5, the check at the bottom. Okay, so that's the process for solving with substitution. Here are a few practice problems, so go ahead and work those out. We'll check those in class next time and answer any additional questions that you have, and there will be an activity that we will work on to practice some of the substitution as well as the graphing from last time. So I'll see you in class.